Hey, what's up, guys? Yeah, it has been a while for me to record a new video. So, this video that I'm gonna to talk about new topics, which is I feel very interesting, and called additive combinatorics. So, additive combinatorics. Okay. I will talk about very interesting theorem in this topics, and I will also talk about various applications. Okay, so hope you guys subscribe to my channel. So additive combinatorics is an interesting topic. Even like basic combinatorics, but we can use number theory or complex analysis or like other discrete mathematics to solve this a lot of interesting problem. Okay, so the first topic that I'm going to talk in this video is called SUMSET. Okay, so let me explain what is this problem address. So given let's say given A and B in some abelian group, so G is abelian group, right? So I can define a definition called SUMSET. So SUMSET of AB, which is A plus B, right, is a set defined by A plus B, where A belongs to A and B belongs to B. Okay, this is called SUMSET. So I want to ask what's how small can SUMSET be? Can SUMSET be by given size? Let's say I given size of A and the size of B. Okay, so I give you A and B, and I want to ask, well, how small can SUMSET be? Okay, so you can easily see that if I take say G to be some real number, just a real number, and I can say B 0, 1, and 4, and maybe B is like say 2 and 3, right? Then I can create a SUMSET, which is A plus B, where is 0, 1, and 4. Oh, sorry. So I can add 2 with this, right? So I can 2, 3, 6, and 3, 4, 7, right? Let's say 2, 2, 3, 6, and 3, 4, 7. Yeah. So there are like 1, 2, 3, 4, 5, right? So A is 3, and B is 2, and A plus B is 5. Okay, so this is like so naively, right? In this case, that 3 is repeated, right? So but naively, I mean, if you pick A, B very random, then you should expect the following, right? You should expect that the sum set A plus B is nearly like A times B. Okay, but but I mean, you can easily build a lower bound, right? So there's a lower bound that one can build. Basically, it's the max, right? A and B. But this is trivial, right? Because given A, any number, if only one number in B, then the max will be A, right? You get A, and the converse is true, right? So this is the simple lower bound that one can be. Okay, but can you create some set which A plus B is linear, right? Like this A, B is order n, and A plus B is also order n, right? So that means that if A is order n, and the B is order n, then we expect that A plus B should be order n squared. Okay, and so the ask is, can we create? So we create where A plus B is order n. Okay, so and it definitely based on this group, right? If you change this group to be very small, then A plus B should be very small. Okay. Okay, so the first theorem that I'm going to do is then when G is a real number, then we have the following trivial bound. So we have A plus B is basically greater or equal to A plus B minus 1. Okay. Oh, so if you take any two real number or subset of real number, then set of A plus B is greater or equal to A plus B minus 1. Okay, so the proof is very simple. Let's say we order A to be A1, A2 up to AL. So A1 less than A2 less than A3 up to AL. And then let's say B is B1, B2, I would say BM. Okay, and B1 is less than B2, B3 up to BM. Okay, and so I want to say that A plus B, this set is at least have this, right? So I should create a sequence of numbers such that they are all different, and the number of it at least A plus B minus 1. And this is simple, right? So notice the following: you have A1 plus B1 less than A1 plus B2, right? Up to A1 plus B3, and up to A1 plus Bm. Okay. Now A1 plus Bm definitely less than A2 plus Bm, right? So definitely less than A2 plus Bm, and A3 plus Bm, and up to AL plus B. Okay, so the number of it is L plus M minus 1. Okay, so proof. So this is very simple proof, right? You just do this. Okay, so when G is a real number, then we can create this. And it's easy to see that this bound is tight. Okay, so the bound is tight. Okay, and the reason is very simple, right? You can just take A to be the 1, 2 up to N, and the B will be 1, 2 up to N. Okay, and then you will see that A plus B is all the number, basically it's all the integer, right, come from 2, and then with 2N. Okay, so the number of it will be 2N minus 1, which is N plus N minus 1. Because all the number must be integer, right? And all in this arithmetic sequence. So obviously, if you take A and B to be two arithmetic sequence, then A plus B will be very small. Okay. Oh, so this is the simple bound that one can achieve. Okay. But now the next question is the following: How about when G is prime, right, or not finite field, right? So C mod P. P is prime. Okay. P is prime. Okay, and this is called this is basically just the prime number. You give a prime number, you can form the field. Okay, so now this is the next theorem that I'm gonna to prove in this video. Another video called Cauchy-Davenport. Okay, so the very interesting is that this is true still in the prime field. So let's say A, B are the prime field, subset of prime number. So subset of this prime abelian group. Then your A plus B is basically greater than equal to. So you have the max, right? So you should have max because finite field is not has at most P, right? So P plus either P or A plus B minus 1. Right. So basically if your A plus B greater than minus 1 greater than P, then it can only be P. So sorry, this is minimum. Right. So if your A plus B minus 1 is greater than P, then you must add up with all, just give all the element in the group, right? So this is minimum of P, A plus B minus 1. Okay, so this is the Cauchy-Davenport theorem, which is very interesting that I will prove in next videos. Also, hopefully this very quick video give you the idea of why additive combinatorics is interesting. Once you follow this Cauchy-Davenport, you will find that this is interesting. There is a very interesting application that about this theory. Okay, see you guys next videos.